Here we shall see how to get a maximum current when cells are connected in series. That means what is the condition which is actually needed here so that the current that is flowing through the external resistance will be maximum. So for that we consider, let's say, n number of cells connected in series, and each cells are having same EMF E and same internal resistance R. Now this combination, it is connected to an external resistance capital R. Okay, let's say that the current which is given out by this combination of cell, let's say it is I. So this I, it will be flowing through the external resistance R. And now we shall see what is the condition for this I to be maximum. Okay, alright. So it is clear here that the total EMF of the combination, because when cells are connected in series, you know, total EMF is E1 plus E2 plus E3. So in this case it is E plus E plus E plus dot 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 up to again E n times, up to n times. So when I say n times mean E plus E n times, it is like 1 plus 1 plus 1 plus 1 up to 10 times mean 10 into 1. So similarly here, instead of writing that E, I will write n times E. That is the total EMF. Again, what is the total internal resistance of the circuit? The total internal resistance, let me denote this by, okay, I will write it later. So similarly for the total internal resistance, we'll have NR, right? And the total resistance of the circuit. What is the total resistance of the circuit? When I say total resistance of the circuit, means the combinations of internal and external. So all these internal resistances are connected in series with the external. So therefore I will write NR plus capital R. So these are the things which we have found. So hence the current which is passing through the external circuit, it should be total EMF by total resistance of the circuit. So what is my total EMF? NE. What is my total resistance? NR plus capital R. Okay, right, so this is my equation 1. Now we shall see about a special case of this equation 1. And the first case is this capital R is very small compared to NR. That means if the external resistance is smaller than the sum of the internal resistances, so in that case what will happen to I? Your I will becomes NE upon, because this R is too small compared to this NR, so therefore this capital R can be neglected. You have only just N small r. So this N with this N cancel. You have E upon R. Now this E upon R, E is the potential, R is the resistance. So potential upon resistance, it is current. So this is current due to one cell. Okay. And the second case, if this capital R, it is very large compared to the total internal resistance. So in that case your I becomes NE upon, because this R is too large compared to the NR, so this NR can be neglected. So inside, in the denominator you'll have only capital R. So again this is N, but this E upon R, it is actually the current due to one cell. So we can write N times current due to one cell. So now looking at these two special cases, we see that In the first case, the current is due to just one cell, but in the second case, the current is equals to the current, it is maximum here because it is equals to n times the current due to one cell. So when the current due to this one cell, let's say it is 1 ampere, the current due to this is 1 ampere, the current due to this is 1 ampere, the current due to this is 1 ampere. So when I say current n times current due to one cells, that means if I have 10 number of cells, then the total current in that case will be 10 times 1, which means 10 ampere. But in the first case, right, the current is due to one cell, so that means the current is just 1 ampere only. So in which cases do we have maximum current? Obviously in the second case, right? So we conclude that in order to have a maximum current in the circuit, this total external resistance should be very, very large compared to the total internal resistance of the circuit.